Okay, so the Mclaren series, Maclaurin just means it's centered at where? Centered at, what does it mean when it's a 0? Thank you, Amanda. Okay, so Maclaurin series just means it's centered at 0, so your x's are just x and x squared. It's not like x minus a and x minus a squared and so on, okay? So some of these Maclaurin series occur so often that if you memorize them, it's just going to save you a lot of time on the AP test. And some of them, it's not like you actually have to memorize them necessarily, but some of them are really, really, really quick to figure out. So if you're super quick at figuring them out, I would say you don't have to memorize them. And it'll just kind of become something that you can write without really thinking about it too much. Like for instance, e to the x. If we're using e to the x, what's the derivative of e to the x every single time we do it? E to the x. So anytime we plug in 0, we're always going to get what? 1. So if we're trying to do this, the first term is going to be 1. The next term is going to be 1 times x to the first over 1 factorial. The next term is going to be 1 times x to the second over 2 factorial. The next one is going to be 1 times x to the third over 3 factorial. You see how quick that is without really memorizing it? It's not like you have to sit down and make flashcards and drill these into your brain or get a tattoo or something, okay? So this one here, pretty easy. Get a tattoo. I'm not sure. They'd probably make you cover it up, but I don't think they should if you're that dedicated. Okay, this one up here, if we look at this side of it, and this is something we was kind of written on most of your quizzes. If you look at this, do you see how it's geometric? And what am I multiplying each time? What am I multiplying by each time to get the next one? Negative x. So this is really geometric, and my r is negative x. So if you're finding the sum, don't you do your a, which is 1, over 1 minus your r? So do you see how that turns into this side over here? It's nice, right? So if you see that, you can go, okay, that looks geometric. I know my r would be negative x, and then you can start listing your terms. Your first term's 1. Same thing with the top one up there. If you look at the top one, it's just multiplying by x each time, so you see it's 1 minus x there, okay? Okay, and then the sine and cosine ones are actually decently easy to memorize. If you're thinking about the sine function, is the sine function even or odd? Odd, right? So if it's an odd function like the sine function is, do you see how it's only using the odd pieces here? Okay, so it's odd on both sides. So both sides are odd functions. And if we do sine of 0, what do we get? 0, which you're going to get 0 on this side if you plug 0 in for x, and you're going to get 0 on this side if you plug 0 in for x. So if you were, confused on that, you'd see that there. And think about sine and cosine. Don't they always oscillate between positive and negative and positive and negative? So it starts positive, negative, and it's just using the odd ones here. With cosine, cosine is an even function, so if you look at it here, it's just the even pieces on both sides, and again, it oscillates between positive, negative, so they're actually decently easy to memorize. Now, I'm not going to tell you that I have these memorized all year round, because I use them for like a couple weeks during the school year, but they come back to me really quick, because they're in there somewhere, Okay, here, the natural log, that one might be, I guess, one of the harder ones to memorize because it's not just super easy to see what it is, but you could always figure it out. How can you figure it out if you don't have them memorized? What are the steps that you were doing in the last, or that we did in part 1? Yeah, you start with your function, right, which is the natural log of 1 plus x. And then you take the derivative, and you take the next derivative, and so on, and then you find those at what spot? At 0, and then you can always plug it in. So if, one of these isn't memorized, it's really not a big deal. Inverse tangent, I'm going to show you on the next page a way that you can go about finding the inverse tangent. Not that you would probably do it that way, but it's just kind of neat how all this works together. And on the free response questions, sometimes they'll write a free response question that, I've never seen anything like it before, but it's like you can figure it out if you really understand what you're doing. So through the notes, don't think like, oh man, I'm going to have to do this on the AP test, but think, okay, I might have to think like this on the AP test. So if you have questions, just ask. Okay, what do you notice about sine and inverse tangent? They're not the same. There's no factorials. Otherwise, they're the same, and that's sine and inverse tangent. And we'll talk about why that happens here later in the notes. But yeah, everything looks the same except for there's no factorials down there. So if you remember that those are kind of connected, you'll remember that one too. Okay, so over here, what our whole goal is here is we're going to try to find what the inverse tangent of x is. So we're going to do it a very different way. Obviously, we know inverse tangent of x is this here. We're going to find it in kind of a roundabout way, but I've seen them put something similar to this on a free response question on the AP test. It wouldn't be like they'd give you this and you'd have to do all these steps, but maybe between one step and the next step you'd have to do something like that. Okay, so this one here is on the previous page, right? Isn't that one of the geometric ones? What's my r equal to? Negative x, right? So then you get this part here. Now, if we're trying to do 1 over 1 plus x squared, and the reason we're trying to do 1 over 1 plus x squared is y. How is that related to the inverse tangent? It's the derivative, right? So I'm going to end up doing the integral of this in a minute. Okay, so I want to get this here to turn into this here. So what do I have to replace my x with? X squared. So that means I'm going to replace all of the x's with x squared. So that's what it says here. Substitute x squared for x. So then let's write what we're going to get. So we get 1 over 1 plus x squared. If we replace all the x's with x squared, the 1's still just going to be 1. Instead of minus x, we have minus x squared. The next one's going to be plus x to the 4th, and so on there, right? And I'm going to put plus dot dot dot. If you want to put minus dot dot dot, it's fine. Okay, so here it's still a geometric series. Now our r is just negative x squared. We're going to integrate both sides. So that means I'm going to take this whole thing, and I'm going to put it down here. And if I'm integrating, what does that mean? Integral, right? So we're going to put the integral in front of both sides of it. And these are equivalent because we have the dot dot dot. Okay, they're not like nearly equivalent, they're equivalent to each other. So if we do the integral of this side, it's going to be equivalent to the integral of this side. Okay, so what is the integral of the left side here? Inverse tangent, right? And the integral of 1 is going to give me x. And then this will be a third x cubed, which we'd probably write as x cubed over 3, so it looks more like what's on the previous page, but same thing, right? Next one will be a fifth x to the 5th, or x to the 5th over 5. And so on there. So you can come up with these things different ways, and sometimes they'll ask you to, like, I don't know, go from one thing to another thing, and you're like, oh, if I took the integral of that, I would get this, so I'm going to just do the integral of the whole thing to get there, or I'm trying to get from one place to the next, and if I took the derivative, I would get there. So you just have to, I guess, recognize a lot of trig things is one of them that they like to use. Okay, now down here they love, now this here I'm going to be writing a lot and explaining a lot, okay, but they love this part that I'm going to do down here on the or on the multiple choice stuff on the AP test, trying to get them to match up. So this looks the same as the series for sine of x, but without the factorials. That's not the question that I'm doing down here. I'm doing kind of a separate question. Okay, so we're going to use what we have up here. And we're going to find f of 0. And then we're going to find f prime of 0, and we're going to find f double prime of 0, and so on here. So on the AP test for like multiple choice, they might ask you to find or tell them what the third derivative at 0 is, and you're like, what? Like you have something like this and you're not sure what they're even asking for the third derivative at 0. If they're asking for the third derivative at 0, which term am I going to be using in a Maclaurin series? Oh yeah, I'm going to be using the one that's raised to the third power, right? So you just have to recognize that you're pulling these pieces out. So we'll go in order here. And we'll actually go all the way to the 5th one. That way we get a couple good practice ones here. Some of these are really quick, so we need to have extras to get some good practice. Okay, so if I'm trying to find f of 0, what is f of 0 going to equal? 0, because there's nothing there, right? There's no term that's like x to the 0 power, so this one's just 0. What about the second derivative at 0? It's 0 also, because there's no x squared term. And x, the fourth derivative, is also going to be 0, right? Because there's no terms there. These are the ones where you're probably going to see them on your AP test. So let's say I'm trying to do this one. I'm going to show you the systematic way to do it because they're going to get harder, or sometimes they're going to be more difficult than this particular one. So if I'm trying to find the first derivative at 0, I know that the first derivative at 0 times x to the first over 1 factorial is equal to which term up there? Just this term here, right? So I'm going to set it equal to x. Then you can write x to the first or 1x to the first if you want to. And then we have to solve this for the first derivative at 0. So typically what I do is I just go, I'm going to cross multiply these and then solve for it. With this one, it's not particularly difficult. What is my first derivative at 0 going to have to be? 1. We'll get to a more difficult one for you guys, don't worry. And it's not like they get crazy difficult. As long as you understand the concept, they're actually pretty easy. So if I'm doing the third derivative at 0, I'm talking about the third derivative at 0 times x to the what power? Third over I'm going to take the negative when I set it equal to it here. This is just using the Mclaren series. What is that term going to be? So we have the third derivative at a, but our a is 0 because we're talking about it centered at 0 here. X is to the third, and what do we put it over? Not 3. 3 factorial when we're talking Maclaurin series, right? And that's equivalent to which term up here? Negative. So don't forget about the negative there. Okay, it's easy to miss it and then pick the wrong answer here. So we have negative x cubed over 3. So here is where I would just do a quick cross multiplication because it really isn't, it really doesn't take too much time. And if you try to do some of this stuff in your head, sometimes you end up with the wrong answer and you could have gotten an easy, quick, right answer. So I'm just going to take 3 times the third derivative at 0. X cubed, so I'm just cross multiplying this times this equals, and then this times this will be negative, what is 3 factorial? 6 x cubed. Won't the x cubes cancel? And then if I'm trying to solve for the third derivative at 0, I want to divide both sides by 3, and it'll cancel there. So I end up with the third derivative at 0 is negative 2. Okay, go ahead and try the fifth one there. We'll go over it in like 2 minutes, but I want to make sure you can do one of these on your own there. Okay, so when we're doing our fifth derivative, we're doing fifth derivative at 0, x to the fifth over 5 factorial. And sometimes doing the mental math on these can get difficult, so you got to think smarter and not try to do it in such a difficult way sometimes. But our fifth piece here will be x to the fifth over 5. And this one isn't like crazy difficult by any means because it's only 5 factorial, but sometimes they'll be, larger, so, and no calculator, so you end up with them a little bit more difficult. We're going to cross multiply. The x to the fifths are going to end up canceling out, so I'm just going to cancel them before I cross multiply. So I got 5, and then the fifth derivative at 0. And then that's equal to 5 factorial, which is the same as 5 times 4 factorial. So when I divide both sides by 5 there, the 5's end up canceling, so I'm just left with 4 factorial for my answer, which they could actually have as how they write it. And if it's not written that way, you just do 4 times 3 times 2, which gives you what? 24. So we should have 24 for an answer, or 4 factorial. They might keep it as. Obviously, you could get that matched up, right? So questions on that? They just really like those on multiple choice, so I would not be surprised if you have a multiple choice question like that this year on the AP test. Okay, this one here just says, let's try this one to see why there are no factorials when we're talking about the natural log. So we're just going to review what we did in part 1, okay? So go ahead and start with your f of x is the natural log of 1 plus x. And then find your first, second, third, and let's go to fourth derivative. And once we have these, then what are we going to do to them? Once we have all these derivatives, what do we do with them? Not set them equal to 0, but find their values at 0. Yep. Okay, so I'll give you a 60-second head start there. First one's nice and easy. The third one, once you simplify it, it's okay if you don't have these done. They take a little bit of time. Okay, so I'm going to give you a couple more minutes to get caught up there or start plugging in at 0. If you have all that done, then you can start building it. We'll do that in I'll give you like 2 minutes there. Okay, I'm going to go ahead and plug zeros in here and we'll see what we get. So I'm getting f of 0, 0, f prime of 0 is 1. You guys get all these? Second derivative is negative 1, so the negative there. Third derivative is 2, and your fourth derivative is negative 6. Okay, so we've got those, and then if we set this up, if you guys remember, we're taking this one here, and it sits by itself because it's x to the 0 over 0 factorial. So we just start with our 0 there. And then we take this one, and it goes with x to the first over 1 factorial. And then we move to this one, and it's x to the second over 2 factorial. The next one is x cubed over 3 factorial. And then we've got our negative 6, x to the fourth over 4 factorial. So when we simplify this, this 0 obviously just goes away. This is just x, and this will be a minus, and it's just x squared over 2, because 2 factorial and 2 are the same, right? And then this one here, we've got x cubed, and the 2 ends up canceling with the 2 that's here, like 3 times 2 times 1. So we just end up with 3 instead of 3 factorial. But didn't this one take a little bit of patience and time to do? This might be one that you want to memorize, you know, rather than having to try to do this on your AP test.
So right now we're just proving
Yeah, this is, because this is your backup method if you don't have them memorized. You have to go about it this way. And e to the x, is it a big deal to memorize e to the x? No, because it goes so quick, but with something like this, doesn't it take a little bit to get all those derivatives correct? You know, so it's up to you whether you want to memorize them or not. So this is just like what we did the other day. Yeah, it's just more of that. Okay? Let's go to the next slide here and learn something new. Okay? You're going to see it sometimes written like this. So you have to be able to take what we have and write it in this form here. And we'll go back to like your memorize page here, and we will end up writing all of these in sigma notation. Okay, so we'll do that maybe tomorrow or something there. Yeah, save everything for tomorrow. Okay, so this here is pretty important. You might want to star it. This is if we're trying to get something that looks like this written in this form. So if you memorize that, that's fine. Typically, I just look for the pattern and try to write it correctly here. We end up here with, we're just going to start with this piece here. Actually, this piece here. And I'm going to try to write that as a sigma notation. So if you notice, we're always starting with n equals 0 and going to infinity. And this here then would be my 0 term, this would be my first term, this would be my second term, this would be my third term, and my fourth term. So what do you notice is always going on in here with the x? What power is it always raised to? X is always raised to the, isn't it just raised to the n power? Because we're starting with 0, then 1, and 2, right? So x is to the n power. So we could put x to the n in the numerator here. And they're always positive, so do we need to worry about like a -1 piece? Not this time. And then in the denominator, what do you notice is always there? N factorial. So they're pretty easy to write in that form, right? Okay, so let's go ahead and circle that. Okay, and then the other thing that we're going to do is we're going to find the radius of convergence. So how do we go about finding the radius of convergence? Ratio test. So our ratio test, we're going to use the something, yeah. So we're doing our a sub n and our a sub n plus 1. Our a sub n is just what's in here, so x to the n over n factorial. And then a sub n plus 1 is x to the n plus 1. Uh-huh. No, I don't. The summation thing? Oh, what's inside of here? Oh, okay, sure. And then what do we do for the ratio test without looking? Yeah, a sub n plus 1 goes first, and we're taking the limit, right? So we're going to take the limit as n goes to infinity. Absolute value, a sub n plus 1 goes first. And I just wrote it separately so we can cancel it quicker here. And then instead of dividing by a sub n, I'm going to reciprocate it. That look okay? Okay, cancel the x to the n's, cancel n factorials, and then we just leave our limit with the n going to infinity with the n's, which is 1 over n plus 1. And then we've got our x is still in the absolute value, right? And what is this limit going to equal? 0, right? So I've got 0 times the absolute value of x is less than 1 we want it to be. Isn't it always going to be less than 1? So what is our radius of convergence then? Infinity. So our radius is infinite. Questions on that? Okay, now some people end up doing this in a very long way, because if we're trying to find the Mclaren series for this, if we start with our f of x and then we take the derivative and then extra, isn't that going to get like a lot of work because of the product rule going on in there? Okay, you don't want to have to do it that way where you're doing product rule, product rule, product rule. So you want to use the stuff that you already know. So if you go back to the page of the stuff that we want to have memorized, and even if you don't have it memorized, you could come up with it pretty easily. We're going to use this cosine of x here. And I'm going to write it in sigma notation. So I'm going to go ahead and write this cosine of x out on the paper. So this is where it's coming from. You could find the cosine of x by itself pretty quickly, and that would be fine also. Okay, but I'm just going to take it from that page. So let's start with cosine of x equals, and it's an even function, so we're just dealing with the even pieces. And it oscillates between positive and negative. Okay, and if I'm trying to write this in the other form, I'm going to have this be my n equals, this is my 0, this is my 1, this is my 2, this is my 3, and so on. So if I'm trying to write that in sigma notation, I'm starting with n equals 0 going to infinity. And do I have to worry about a -1 piece because it's changing positive to negative? Yes. Okay, so you want to have a -1 to a power. And if you just try the n power, check if it works. If it doesn't work, you can change it to n plus 1 or n minus 1. So if I plug in 0, do I get it to be positive? Yeah, if I plug in 1, do I get it to be negative like I want? Yep, so this looks good for the oscillating part. And then we'll work on the fraction part here. X is always raised to what power? 2 times the n value. 2n is good. Everyone okay with that? Okay, and the denominator is always what factorial? Same thing as the exponent, right? So 2n factorial. Okay, so that's just cosine of x, but what's the difference between that and what we want to find? We want to multiply this by x because we want x cosine of x. So this is cosine of x here. So if you need to write yourself a little bit of a note there, you can. I know we have it over here. So if we want x cosine of x, then we're going to take x times the one that we just wrote. You want to write yourself good notes so when you refer back you can find this stuff. Whoops. And then all you do is you just put that x into the summation notation. So what's that going to turn this to if I put times x in here? What do you get if you have x to the 2n times x? No. What do you do with your exponents when you have the same base? Add them, so you'd get what? X to the 2n plus 1. Yeah, so the rest of it stays the same, but this turns into x to the 2n plus 1. And that's how you'd see it, like for multiple choice to match it up. You know, this would be incorporated into there. If you're trying to do this the long way, you're going to be working for a really long time. So try to think of that. Like, okay, I know cosine of x is really quick. I'm just going to find what that one is. If you don't have it memorized, you can find it quickly. But then you just multiply it by x and you're there. There's a lot of like shortcuts that make these problems way quicker and easier. You'd get the same thing if you did it the long way. You just don't have time to do it the long way. Okay? All right, let's talk about the last page here, and then there's like 48 and 64 and 66 also, but we can look at that tomorrow because we'll just pile stuff onto tomorrow and get as much done as we can. So find the first three non-zero terms in the Mclaren series. So here we've got e to the x and sine of x, and we're multiplying them. So literally you're just going to multiply what e to the x is by what sine of x is. And sine of x is even or odd? Odd. So my first term is going to be what? X, because it's x to the first. And then in the next one's going to be positive or negative? Negative. And my next term, if it's odd, should be what? X cubed over 3 factorial. The next one will be plus. And then I'm just going to put dot, dot, dot here. Okay, because if we only want the first 3 non-zero terms, hopefully, I mean, if I need more, I can always put more, but I'm guessing I won't need more than that. And then e to the x, remember the derivative is always e to the x, and if I plug in 0, I'm always getting what for a value? 1. So my first is going to be 1. My next one's going to be 1 x to the 1 over 1 factorial, so just x. My next one's going to be 1 x squared over 2 factorial, so it'd just be x squared over 2 or 2 factorial, it's up to you. The next one would be 1 x cubed over 3 factorial. I'm just going to write it like that. I don't think we'll need even that many, okay? I'll put factorial there so no one's confused on that. And then you just start like foiling it type of a thing. Another way that people like to do these is making like a lattice box. We're not quite sure how large this will have to be in the end, but you can put like your 1, and then your x, and then your x squared over 2, and your x cubed over 6, or 3 factorial, same thing. And you just start multiplying here. And you don't have to do it this way. You can just do your old-fashioned FOIL. Just don't forget about the negative here. And the first 3 terms would just be like your lowest power ones. So if I start multiplying, I just get x here and x squared here and a half x cubed here. And I shouldn't need another one unless one of these cancel, because that's 3 terms right there, and this one's a higher power. This would be negative a 6 x cubed. So these two will go together. And this is already x to the 4th, so I shouldn't need that, right? This one down here is an x to the 5th, so I shouldn't need that. So this should really give me all the stuff I need. Does that make sense to you guys? So we just have x plus x squared plus a 3rd x cubed, if you combine those together. And it just says find the first 3, so that's all we're looking for there. Okay, this one's similar. Tangent, you just write, and we'll do it tomorrow, because why not? Tangent, we just write as sine over cosine, and then you'd do long division. So we'll look at that tomorrow. Okay, we're kind of out of time for today here.